Today we are going to discuss properties of a determinant. There are various properties of determinants by which we can find values of a determinants in simple way. First, we are going to discuss the first property. That means value of a determinant is unchanged if its rows and columns are interchanged. For this, we take an example of a determinant A, B, C first row, U, V, W second row, P, Q, R in third row. Here, that is row, we can change it to column. This becomes column, this second row becomes second column, third row becomes third column. These two determinants are remain unchanged. The value of a determinant not changed, which we can simply so that R changes to C, that is row become column and column become row in symbol way. And that means we can say that determinant A is equal to determinant A dash, where A dash is known as a transpose of a matrix A. Number 2 property, if we interchange any two consecutive row or consecutive columns, then sign of the determinant changes. Here same determinant we have taken, and these are known as a row. We take two, here we get two row, that is two consecutive row. We can interchange these. These come here and these come here. That is, we have to change two rows change, then we get a minus sign. Here also we can change in column. That is the first column, this is the second column. We interchange, first column goes to second column and second column goes to first column. The interchange, the consecutive columns, two consecutive columns are interchanged. Then we get a minus change, which is shown as a C1 changes to C2 or C2 changes to C1. That means we get a minus sign in second property. Value of the determinant unchanged, but sign is changed. That is the second property. Property 3. If any two rows or columns of a determinant are identical or proportional, then its value is 0. For example, we take a determinant of third order. First row ABC, second row UVW, third row ABC. Now here we can see that the R1 is equal to R3. So first row and third row are identical, so it is become 0. Here also second row and third row are proportional. That is R2 proportional to R3. This row and this are proportional, so this is equal to 0. In this case, in case columns, we see that C1 and C2. This C1 and C2 are identical, so it is equal to 0. Here also C1 and C3 are proportional, so it is equal to 0. That is the third property. Number 4, if each element of a row or column of a determinant be multiplied by a number, it may be positive or negative, then its value is also multiplied that number. For example, we take a number k, that is the determinant. We take a number, the k is multiplied in first row, then we can each element of the first row, then we can take common from first row. Similarly, this k can be multiplied in third columns. That means from this property we can say that if we multiply a determinant by a number, then that number is multiplied only one row or one columns. Any 3 row, out of 3 row we can multiply it only one row. Out of 3 columns we can multiply k in one column also. Number 5 is if each element in a row or columns of a determinant is a sum of two numbers, then the determinant can be written as sum of two determinants. Here we can take an example, that is the determinant. This first row is a sum of two numbers, no, a plus alpha, b plus beta, c plus gamma. That is the first row. So this determinant can be expressed as a two determinants. That is first determinant a b c. That is a b c. Second row and third row same. And second determinant, that is alpha beta gamma. Second and third row are same. In this case, the first row is sum of two numbers. Similarly, this property can be applied if each row of a column is a sum of two numbers. Then also we can express it as a sum of two determinants. That is the property 5. 2 is element of a row or column of a determinant. The equimultiplier of corresponding elements of other row or column are added or subtracted. Then value of the determinant remain same. That is Ri means ith row changes to ith row plus k into z row. Similarly, in column Ci equals to Ci plus k into Cj. For example, we take an determinant whose rows are A, B, C, U, V, W, P, Q, R. If we apply this, that is C1 changes to C1 plus k into C3. That means C1 this plus k into this. Then we get right in C1. That means A plus k into C, U plus k into W, P plus k into R. And second and third row are same. Then this determinant and this determinant are same. In case of row operations, but in case of in row, same determinant, here we can change this R2. R2 changes to R2 plus k into R3. Then also same. And then here the second row is this. Second row changes to second row plus k into third row. U plus k into P, V plus k into Q, W plus k into R. That means these determinants are remain same. Another property, if A is a matrix of order 3 into 3, then determinant of Ka is equal to K cube determinant A. Since this K is multiplied by A is a matrix, so K is multiplied all 9 elements. That means K is multiplied 3 rows or 3 columns. If we take common, then 3K comes out. 3K equal to K to the power 3. Number 8, if a row or a column of a determinant consists of all 0, then value of the determinant is equal to 0. That is determinant this equal to what? This A, B, C, U, V, W, and third row is 0, 0. That is this row all elements are zeros, therefore value of the determinant is equal to 0. Here also each element of the third column is 0, so value of the determinant is 0. Very simple property 7 and 8. Main property is this. Generally these properties maximum use this property. That is the properties of the determinants. In exercise 4.2, in textbook, using property of the determinant and without expanding, in exercise 1 to 5, prove that. Number 1, that is the we have to prove this equal to 0. We take left hand side, this equal to this. Now we apply C1 changes to C1 plus C2. Then what happens? C1, that is C1 this, that is this plus this, x plus a here also y plus b, here also z plus c, and a, b second column same, and third column also same. Y plus b, z plus c. We apply this. Now we have to see this equal to these columns are identical, so this equal to 0, that is right hand side. Now why this equal to 0? Because C1 is equal to C3, that means identical. That is the number 1. Number 2, now we have to put this equal to 0. Taking left hand side this, if we apply this equal to, suppose we apply suppose R1 changes to R1 plus R2 plus R3. Then we get what? Then we get R1, that is this plus this equals to 0. BB cancel, CC cancel, A cancel, that becomes 0. Here BB cancel, A cancel, and CC cancel, so this equal to 0. Here also A cancel, BB cancel, CC cancel, so 0. Others two are same. B minus C, C minus A minus B, C minus A minus B, B minus C. Since all elements of first row is equal to 0, this equal to 0, this implies equal to right hand side. Okay. Number 3, left hand side. Here we apply C1 changes to C1 plus 9 into C2. Then what happens? We get C1, that is 2 plus 9 into 7, 9 into 7, 63 plus 2 whole 65. Here 3 plus 9 into 8 whole 75. Here 5 plus 9, 9 the 81 plus 5, 86. Others two columns are same, 7, 8, 9, 65, 75, 86. Here we have seen this row column and this column are same. So this equal to what? This equal to 0. Why? C1 is identical to C3. That is right hand side. This is only using properties. Here also we apply C2 changes to C2 plus C3. Then what happens? First column are same, 1, 1, 1. Second column becomes BC plus AB plus AC. Here CA plus BC plus AB. Here AB plus CA plus BC. Here also same, A into B plus C. Here B into C plus A. Here C into A plus B. Now in this column, that means second columns, all three elements are same, so we can take common, or we can say this first column and second column are proportional. That means C1 proportional to C2, so this equal to 0. Because C1 proportional to C2, therefore right hand. Number 5, we take left hand side. Now we apply R3 changes to R3 plus R2 plus R1. Then it becomes first row and second row same, B plus C, Q plus R, Y plus Z, C plus A, R plus P, Z plus X. Here A twice, B twice C, to take A plus B plus C, here 2 P plus Q plus R, here 2 X plus Y plus Z. Then we get this. Next we apply 2 take out from the determinant, then we get B plus C, Q plus R, Y plus Z, here C plus A, here R plus P, Z plus X, here A plus B plus C, P plus Q plus R, X plus Y plus Z. Next, go to in this way. Next, 2. We apply here. We apply R1 changes to R1 minus R3. This minus this B and C cancel, so it becomes minus A. Here becomes minus P. Here becomes minus X. And same step, we apply R2 changes to R2 minus R2 minus R3. That means this CA cancel, so it becomes minus B, here minus Q, here minus Y. And here we get A plus B plus C, P plus Q plus R, X plus Y plus Z. Next, here also minus 1, we can take minus 1 common. From second we get minus 1 common, we get minus 1 whole square. Then this equal to A, P, X, here B, Q, Y, here A plus B plus C, P plus Q plus R, X plus Y plus Z. Now it becomes 2, 1 square is plus 1, therefore 2. Here we apply R3. Then this to R3 minus R2 minus R1. This means this minus this in R3. So first row and second row same. A, P, X, B, Q, Y, this minus A, B cancel, so it becomes C. Here P, Q cancel, it becomes R. Here X, Y cancel, so become Z. This equal to the P, Q star same, therefore we can say right hand side. That is the